In this chapter, we are going to implement authorization to further improve the security of our system. In the previous chapter, I showed you how to implement authentication using an external identity provider, and authorization adds an additional layer of security on top of this. Authentication allows us to know who is the current user trying to access our system, and authorization allows us to determine what the current user can do. There are three types of authorization that I'm going to show you: role-based authorization, permission-based authorization, and resource-based authorization. So let's see how we're going to implement authorization in the clean architecture. Let's start by implementing support for role-based authorization. I'm going to open up the API project and navigate to the user's controller. I want to introduce authorization on the get logged in user endpoint. If you don't already have this endpoint, I suggest that you download the code from the start of this chapter because I made some improvements in the background. ASP.NET Core has native support for role-based authorization. You have to specify the authorize attribute, and one of the possible arguments for this attribute is setting the roles. This property expects a comma-separated string containing the roles that I want to give access to this endpoint. Let's say that I want my authenticated users to have the registered role. Now, I don't particularly like hard coding these values here, so what I'll usually do is create a static class, for example in the controllers folder. Let's call it roles, and let's make this class static. Now I can expose a constant that's going to represent my concrete role. So let's call this the registered role. For the constant value, you can type it out, or you can use the name of operator if you want your role to have the same name as the constant. What this allows me to do is to go back to my user's controller and replace the register string here with the constant value on my roles static class. This approach promotes reusability because I can specify the constant in multiple places, and it's also less error prone. The next thing we're going to need is to be able to manage the roles in our application. So let's go ahead and create a role entity in the domain project, and I'm going to place it inside of the users folder. Let me add a new class inside that I'm going to call role. The role is going to be a sort of an entity, but I'm not going to use the entity base class here because I don't want to use a GUID as the primary key. I'm going to have two properties on my role. One is going to be an identifier, and I'm going to use an integer for this. And let's use an init setter so that this can only be set once when initializing the role. The next property that I'm going to need is going to be the name for our role, and it's also going to have an init setter. I'm also going to expose a public constructor for my role that will be accepting an ID and a name, and I can define a public static read-only field that's going to contain my predetermined roles. So let me create one, and I'm going to call it registered. We're going to give this a value of a new role, and I'm going to specify the ID as 1 and the name as registered. This is the same role that I was referencing in my controller, only now I'm defining it as part of my domain, which is going to allow me to manage my roles from the domain layer and even seed them using EF Core. I'm also going to create a navigation property that's going to point to the user entity, and I'm going to use the iCollection interface, and let's call this property the users. I'm going to give it a default empty list value, and this will be enough for my role entity. The approach that I'm using here doesn't strictly follow the domain-driven design principles that we were using so far. However, I consider this a more practical way to manage my roles in the domain. The next thing we need to do is to go to our user and also make sure that the users have a collection of roles. So I'm going to create a private read-only list containing my roles, and let's give it the name of roles with a default value of an empty list. This will allow me to encapsulate the roles for my user so that they can only be added or removed using the user entity, which makes our user a kind of an aggregate, and where we are going to assign the role is right after creating the user. So for example, I can say user roles, and what's interesting is that I'm able to access the roles private field because I'm still inside of the user class. So now I can say add, and I can access the registered role and assign it to the newly created user. If you need to support more than one type of role, you can pass in the role as another argument to the create method, for example, right after the email, or you can have dedicated factory methods for each type of role that you want to support. One more thing I'm going to do here is to expose another property that's going to return a read-only collection of roles, and I'm going to give it the same name, and the value of this property will be the roles backing field, and I'm going to call toList to make a copy that's going to be returned as the read-only value. If we go back to where the user is created, it is inside of the register user command handler. In the handle method, I'm calling my static factory method, which is going to instantiate a new user, assign it the role, and then attempt to register this user with Keycloak. And I want to discuss two aspects that are important for our implementation. First of all, I'm not storing the roles as part of my identity provider, which in this case is Keycloak acting as an external service. So I'm using Keycloak only to be able to verify who the current user is. In other words, we are using Keycloak for authentication, and we're going to implement the support for authorization as part of our system after we have already authenticated the user. This approach gives us more control over the authorization aspect, and it also improves the flexibility of our solution. The second aspect that I wanted to discuss is the fact that we are using EF Core under the scenes, and in the user repository, I'm calling the add method to insert my user before I complete the unit of work and persist the changes in the database. If we go to the user repository implementation, this will actually be the repository base class. And all that this is going to do is to add my entity to the database context. If you know how EF Core works under the hood, you might realize that we have a slight problem with how EF Core treats existing objects acting as entities, in this case the registered role. EF Core will attempt to insert this into the database, which is going to cause a duplicate key exception. So here's how I'm going to fix this. I'm going to make the add method virtual, which is going to allow me to override it in the user repository. So if I go to the infrastructure layer and navigate to the user repository class, we're going to override the add method. And what I'm going to do here is to iterate over all of the roles on my user entity and attach them to the database context. So I'm going to say user roles, and then for each of my roles, I'm going to say database context attach and pass in the role. This will tell EF Core that any roles present on our user object are already inside of the database and you don't need to insert them again. And now I can say database context add and add my user to the change tracker so that it's going to be persisted when I call save changes async. Now that we are in the infrastructure project, I'm going to add the EF Core configuration for my role. So let's call this the role configuration and let's implement the required interface. This will be the iEntity type configuration. I'm going to specify the role as the generic argument, and let's implement the configure method. First, I'm going to configure the table, and let's call this the roles. Then I'm going to say that the primary key of this table will be the role identifier. So let's say role ID. I'm also going to configure my relationship with the users table. So I'll say that role has many, and then I can specify the users, which is a navigation property. The user entity could also have many roles. So I'm going to say that the user has many roles, and this is enough to configure my relationship. And I can also seed some initial data for my roles table by calling hasData, and I'm going to specify the registered role as the one that will be seeded when I run my migration. So let's create the database migration. This is the migration that EF Core created for us. You can see that we are going to create a new table in the database called roles. It will have the columns that we configured. We will also create a new role user table, which is a many-to-many relationship table between the roles and the users tables. And we're also going to seed our initial data in the roles table, which is just the registered role with its corresponding primary key. Let's go back to the users controller for a moment, where I want to discuss how roles-based authorization actually works. We use the authorize attribute to specify the role that we require authenticated users to have to be able to call this endpoint. Otherwise, they are going to get the forbidden response telling them that they do not have the required access. ASP.NET Core uses a specific claim on the JSON Web Token to determine if the user has this claim. So let's go ahead and register a new user that will have the registered role assigned, and then let's try to access this endpoint. I'm going to send a post request to my API to register a new user that will have the registered role assigned. You can see we get back a 200 OK response, and now I can try to log in my newly registered user using these credentials. We get back an access token, and let's go ahead and inspect the contents of this token. I'm going to add the value of my JSON Web Token, and if we examine the payload, you can see that my user has the identity ID in the subclaim. However, there is no claim matching the expected claim for roles in ASP.NET Core. There is a roles claim which is specific to Keycloak, and this again brings up the point of how you want to manage your users' roles. I chose to manage them inside of my own application, which means I need to take care of somehow adding them to my claims. So I'm going to show you how to do this in ASP.NET Core. ASP.NET Core has support for modifying a user's claims. You can do this through the iClaims transformation interface, which I'm going to use inside of the